Greetings, the Astro 30 here yet again, and welcome to another exciting episode of the lab. Now, I've got a new acquisition which I'm going to review in this video, and it's also an early Christmas present to myself. You can probably already tell from the title what this is, but we'll open the post bag and to reveal that it's wrapped up even further. Well, isn't that special? Okay, so I'm going to have to carefully get this open without damaging the box inside if I can help it. Taped it up well. There we go. So I've got myself, I believe that this is pronounced FNIRSI. But someone in the comments may be able to correct me on what the correct pronunciation for that is. For now, I'm just going to call it FNIRSI. And it's a 1014D digital storage oscilloscope, or DSO. Now you can find these all over eBay for around the $280, $290 mark. I actually bought this 2 and a bit weeks ago when it was Black Friday and got a, I think it was 20% discount off, so I only paid $270 in the end, which is not bad. So I'm going to open up the box somehow. Maybe if I turn it the correct way around, it might help. Lovely package box, I must admit. Now this is a Chinese oscilloscope, but it's was from an Australian supplier. Now here is the plug adapter. And I did ask for AU plug, but they gave me an American one, so that is practically useless. So this is 5 volt at 2 amps. So yeah, this may not prove to work. I might have to buy another one. I did specify an AU plug, but they didn't provide one, which is annoying. So I'll take this out of the box. And yeah, they didn't supply an AU plug. So here's the scope. Here is, well, a USB lead to power adapter. So I have got another power supply that I can test it with. There's just a USB-A to USB-A cable. That'd be for data acquisition. One of these clip lead, test lead things. You'd use that most likely for the built-in function generator output. A set of 2 oscilloscope probes, nice. And the instruction manual. So I'm not very happy that it did not come with the correct plug. So anyway, there's a little FNIRSI card thing that came with it. I'm not sure what the purpose of that is, but anyway. So I'll take off this, and it's vacuum wrapped, which is nice to see. But as we can see straight away, it's got a nice large display. I believe that's like 9-inch or something. I can verify that with the instruction manual. And so I need to just carefully get this plastic wrap off without scratching the unit. And there we go. That's such a satisfying thing. And I've been waiting for ages for this actually. It's been about 2.5 weeks I think. But because we're coming up to Christmas time now, Australia Post delivery is going to be pretty slow. So there it is there in all its glory. I'll take the screen protector off in a minute. The reason I bought this is because I wanted a, well, semi-decent oscilloscope. Now I will preface this by saying that this is not a professional oscilloscope. This is an entry-level oscilloscope, so it's only basic. And I don't think it has a math function or anything on it, although I haven't looked at the instructions. However, here's our little controls here. That's for channel 1, channel 2. I mean, I'd have to read the manual just to make sure. It does have a little handle here on top, which is nice, so you can carry it. So over here is a bunch of functions: run, stop, auto. You got your H and V cursors. S-pick, which I'm not sure what it does. Menu. S-way, I'm not sure what it does. This one looks like it's for the function generator, because that's above the generator output, which you can't quite see off screen. And here's channel 1 and 2. And I believe over here, I reckon would be for time base. I'm not sure, maybe something else. I'd have to like really play with it. That's what she said. We got a power on off button down here, a USB interface, and a bunch of selection keys. And over here on the right of the screen we got function 1, 2, 3, 4, 5 and 6, and a gen button. So, well, if it's got function keys, probably might have a math function on it. Anyway, I'm going to have to find out what voltage this takes and what polarity, and it's not marked on the back, which is positive, which is negative. It says, here's all the specifications for it. Bandwidth 100 megahertz, sampling rate 100 giga samples per second. Number of channels 2, input impedance 1 mega ohm, resolution 800 by 480, that's the screen. Rise time 3 nanoseconds. Storage depth 240 kilobits, sensitivity 50 millivolts to 500 volts. Time base 50 seconds to 10 nanoseconds. Trigger, sign, nor auto. Coupling AC DC. Input voltage 1 times is 40 volt, that's in DC. Cursor time, volume. Screen capture 1000, waveform, storage 1000, measurement 12 types, generator support, signal type 14 types, intercept output support, size 310 millimeters by 145 by 70. But it doesn't actually say what polarity that is. So I'd have to use a supplied cable. So that means I'm going to have to go out and probably buy myself an adapter just to power this, which is going to be annoying. But you could probably power it off of a USB socket on a computer, but considering it takes up to 2 amps, that might be a bit of a problem. So what I'm going to do is I'm just going to go grab my other power adapter. Never mind, I found this stupid looking thing in the original post-pack bag that I opened first. I didn't check, and that earth is, well, bendy. So I've actually got an adapter which will adapt this, which is doesn't really fiddle that well either, to my type of power, but it was a tight fit, that's what she said, but it's now in there. So I plug that into that, plug this into there. I'll turn the power on. Ooh, we have a screen. Well, look at that. That's kind of special. Now, I am going to have a look at the instruction manual in a minute, but what I want to do is just, you know, I might as well pull the screen protector off now. That is also very satisfying. The other reason I bought this oscilloscope was because of the screen size. It makes it easier for filming. Let me just grab... Oh, look at this Ziploc bag. That's nice. Let me grab one of these probes out and just see if I only wanted one. I got both, but okay, cool. I just want to see if we have an input or an output display, I should say. So I'll leave that other lead over there. I'll plug this into channel A. There we go. Right. Yeah, it looks like we've got a display. Nice. Okay, so that is working. I haven't calibrated the probe yet. What we'll do is I'll unwrap this other clip lead thing. I know you can't see what I'm doing, neither can I. Alright, so I'm going to connect that to the generator output, and I'll remove this, well, try to, there we go, remove that end bit, and we'll just connect the generator directly to the scope. And that's a cursor. That's nothing. What are we on? Times 10. There we go. We've got a square wave now. Isn't that nice? So the probe could use calibrating. I am not sure how you adjust the frequency. I'd have to read the instructions as to what you're supposed to do with that. I think that's more of a calibration output than anything else, although there is a gem button here. Gem 1000 Hertz. I think that's what you do. There we go. You use the cursor keys. Step, half, full, exponent, logarithmic, multi-audio, custom, sine. There we go, we've got a sine wave. And its frequency is currently 1000 Hertz, but I don't know how you change the frequency. Oh, you just hit the OK button. There's our time base. Okay, so that's 10,000 Hertz, which is 10 kilohertz. So that's 1000 kilohertz, which is 1 megahertz. And the resolution's still pretty good. Okay, so I now know how to use the generator. We're at 10 million hertz, which is divided by 1000 is 10,000 kilohertz, which is 10 megahertz, I believe. And yeah, the resolution's starting to not look too great, and considering, yeah, the sine wave's not that great. So I'm going to go out on a limb and say, well, we know that function works. And there we go. I don't know how you change the amplitude though. Yeah, there's no amplitude function there, so that's not very helpful. But we can see that it's working. I'm quite happy with that, so I'm going to change the input to channel 2. And yes, we do actually have an output, even though the cursor is not that great. It's 1. So I need to make it trigger somehow. Anyway, that I can figure out a little bit later, but at least I know that it's working. Okay, so it might be a good idea now to have a quick gander at the product instructions, as they call it. 2-in-1 oscilloscope, signal generator. Right, that just tells you how to move the cursors, I guess, and everything else. So number 7 is the baseline position of channel 2. Indicates the arrow is at the position of 0 volts. Potential. Okay, so it doesn't actually tell you how to change that. So button function diagram. So we've got run pause button. Yes, it's all fairly small. 33 is the function button start function 1. So 33, the first column measurement parameter selection button. After the measurement block diagram pops up, you can select according to the navigation key or the knob next to it. Alrighty. Yeah, okay. So let me just go back a page to here. Number 19 is the channel 2 vertical position adjustment knob. Rotate clockwise to move up, rotate clockwise to move down. Just looking for trigger. It doesn't appear to be any notation of how to adjust the trigger. 28 trigger voltage Y position adjustment knob. So that's 28. That is, well, okay. What's the original button do? 25. 25. One key return to center button after clicking this button. Channel 1 and channel 2 vertical position, trigger X horizontal position, trigger Y vertical position will return to center. So if I were to press the original button, everything goes back to its default. But what I want to know is how to change the trigger. Okay, so set trigger edge. Click edge to switch rising edge, falling edge. Edge. I don't see an edge button. No, I don't. Well, oh, it's over there. Okay. Right, that's on that side. Right, so these instructions aren't really all that helpful to a lot of people. I mean, it just tells you how to use the signal generator and what some of the buttons do. I mean, I'm not really all that interested in all this other stuff because it doesn't really give you that much information. So, alright, it's just a general overview of what the functions do. I think I've got an idea of how the trigger works now. Alright, so they say press the edge button. Okay, that's all that does. So that's the trigger there. Okay, so I'm not sure how you... Look at that misspelling down there. That's how they spell waiting. Yes, okay. Right. So that automatically triggered. Oh, that's going to be annoying. It's only got one trigger. Yeah, okay. So anyway, in a nutshell, that scope is working perfectly fine. I'm pretty much just playing with it right now. Anyway, so yeah, it'll function for what I need it to do. And yeah, there are no math functions. But I haven't been through the function menu yet. So over here, F1 brings up all of this information, like voltage peak to peak, and that should be displaying on the screen. Oh yeah, over here on the right, voltage peak to peak is 2.56 odd volt, and it's showing. So these functions are for each of these down the side here. So at the moment it says V average, so I could probably change that to VRMS. Hit OK. So now it's displaying voltage peak to peak, VRMS, the frequency down there, which is what that one's set to. And of course channel 2's voltage peak to peak, voltage average. So I'll change that to voltage RMS. It doesn't have anything else there except duty cycle and all that sort of stuff, but it doesn't have like what conversion into watts or whatever. So that's how that works, but I'm still not 100% sure how you actually change the amplitude of the generator signal. So yeah, I might just have a quick look through the user manual again. Yeah, so unfortunately there's no function for adjusting the output voltage of the waveform, but you can use this little thumb wheel, pot, whatever you want to call it, to adjust your type of waveform, frequency, adjustment number, etc. I seem to have lost sine wave now, I don't know where it's gone. There it is, and that does nothing to the duty cycle, because duty cycle only is effective on square waves. So if I go back to square and then go over the duty cycle, see, that changes our duty cycle, which usually is always 50% normally when you're generating an output. There is a 50% button over here, that did nothing. Okay, so I'll put that back to 50, 50, and put that back to sine. Okay, so that's kind of the only annoyance that I've got with this scope, is you can't adjust the frequency generator's voltage output. So for testing amplifiers and stuff without a separate generator, yeah, you'd probably have to put a little attenuation pot in between. However, I've still got that other oscillator. I don't really need to use the internal generator if I don't want to. Also, the other good thing about this is, because of the way it's powered, this oscilloscope is actually isolated from the mains earth. That means the ground lead on the end of the probe is also isolated from the earth. And I lost the signal because the lead came off. So that means you are not going to damage your oscilloscope when testing high voltage equipment that is earthed by earthing the oscilloscope in the wrong point of the circuit, if you know what I mean. So you're not going to blow the equipment up, and you're not going to blow the oscilloscope up, especially for valve equipment, but you're going to want for that at least an 100 volt probe, or times 100 probe I should say. Times 10 gives you a maximum of 400 volt DC, so times 100 would give you 4000. Now, I'm not going to go too much more on with this video about this, because, well, it's just a basic oscilloscope. It gets the job done, put it that way. So I'm going to say that it's worth the money. You can find these all over eBay and probably Amazon, but I probably wouldn't get anything from Amazon now, considering there seems to be a few problems with the Amazon website selling junk, unsafe gear, or stuff that just simply doesn't work. So I would go with a reputable seller like eBay, and there's probably the website that this comes off of directly. You can get it directly from their website. It is a Chinese-made oscilloscope, but it's, well, most of them are now anyway, but it is a decent oscilloscope for the price. As I said in the beginning, this is an entry-level scope. That means it's basically for the hobbyist. It's not for a professional service technician or anything like that, or even an automotive technician, whatever. It's more of for the hobbyist that wants to measure a voltage in a circuit, either be a digital circuit or an analog circuit, and see if there's a waveform there and that it looks like it's supposed to be, according to whatever other data you have. So that's going to be it for this video. I am happy with it, apart from the generator not having a volume or amplitude adjustment for it. Other than that, yeah, it's fine for what it is. I don't like the power adapter, but it is what it is. Anyway, I'm going to leave this video here. If you enjoyed it, please remember to rate, comment, subscribe below. You can always follow me on Facebook, and the links are in the description as usual, guys. Anyway, if I don't upload another video before then, happy Christmas to everybody that's subscribed. Hope you have a good and safe one. And guys, honestly, please drink in moderation. Don't go to excess, especially on New Year's Eve and stuff like that. Don't get pissed as farts. Well, okay, on New Year's Eve, I'll let you get pissed as farts, but if you're going to get pissed as a fart, do not drive anywhere, please. Alright, we already have enough problems in this country around Christmas time with people doing stupid shit. So, anyway, this is the Astro 30 saying, see you later, have a great day and a great Christmas.
Bye.